Lesson 43 is simplifying rational expressions. We are going to be dealing basically with variables. So expressions are fractions with variables in the denominator. That just means that obviously there's a letter in the denominator. So we'll just jump right into examples. We're going to identify a few things and recall some definitions. What would make a fraction undefined? Just like slope would be undefined. Levi, how would that happen? Levi, your voice has changed so much. Okay, yes, anything over 0. So if it is undefined, then the denominator will be equal to 0. So when I say what are the excluded values, we're going to take the denominator. So here it is 4x. We're going to set it equal to 0 and figure out what the excluded values are. Okay, so all I have to do is divide by 4 on both sides. What is 0 over 4? It's just 0. So what would make this undefined? When x is equal to 0. So therefore, because we don't want it to be equal to 0, we would have to say that it is not going to be equal to 0. So what are excluded values? X cannot be equal to 0. Okay? So this would be called an excluded value, because that would make the entire thing incorrect. Okay? So that would make the expression undefined. That would be part A. Let's do part B. Part B gives us 2x plus 1 over x minus 4. So the only part of interest, again, because we're just identifying excluded values, is the denominator. So we take our denominator, x minus 4, we set it equal to 0, and we try to solve. So in order to solve for x, what do I got to get rid of? The 4. How do I get rid of it? I add 4 to both sides. Good. So that goes away. I'm left with x equaling 4. And because we don't want it to equal 4, we say that x cannot equal 4. This is our excluded value. Okay, and if you ever need to check it, all you do is just plug it back in and see if it equals 0. So up here we would have said 4 times 0 is indeed 0. Here we say 4 minus 4 is indeed 0. Okay, so these are really quick. On C, most people look at these problems and go, oh my gosh, this is going to be so hard, because they throw all this random stuff in the top, but we're not worried about what's in the top. We're worried about what is in the denominator. We're not worried about the numerator, just what's in the denominator. So 3x plus 21 is in the denominator. So I take it, and I set it equal to 0, and I solve. So first step, I remember I'm doing order of operations backwards here. I want to get rid of addition and subtraction first. So what do? Subtract 21 from both sides. Good. If my pencil will work, we will definitely do that. There we go. So I have negative 21 on this side now, and I have 3x on this side. Now I can get rid of my multiplication. How do I do that? Divide by 3 on both sides. Good. So x, therefore, cannot equal negative, don't forget the negative, 7. And I'm good. And again, I can double check this. 3 times negative 7 is negative 21. Negative 21 and positive 21 make 0. So it's just a really quick check. Any questions there? Okay. Example 2. It says, so we're going to have to simplify this one. 54x plus 9 over 4 plus x. So I still have to identify excluded values. So I'm going to take my 4 plus x, I'm going to set it equal to 0, I'm going to identify my excluded value. I'm going to move my 4 to the other side by subtracting it to both sides, and x cannot equal negative 4. So there's my excluded value. I'm done with that part. I want to try to simplify this as best that I can. If I can, I want to try to simplify it. So here we go. Is there anything that I can pull out of both of these terms? What can I pull out of both terms? Say that again. Well, there's not an x in this one. I'm only looking at the top. Okay? I'm only looking at 54 and 9. Remember when we did our least common multiple stuff? Or our greatest common? So we can pull out a what? We could pull out a 3. Is there anything bigger than that? We can pull out a 54 and 9. Here's a hint. 54, 5 and 4 added together make 9, right? So we can pull out a 9, like Bailey said. So if I pull a 9 out of 54, what am I left with? I'm left with 6. And as soon as my pencil decides it wants to work again, we'll write that down. There we go. Alright, so 9 coming out of 54x leaves me 6x. And 9 coming out of 9 leaves me with what? 1. There we go. And they have 4 plus x. I'm going to write this in standard form. Standard form puts the variables up front. I don't like writing numbers before variables, so I'm going to write it as x plus 4. Okay? I hope that helped us. I don't really know if it did or not. Nope, it doesn't look like it did. The only way that I could cancel out anything is if it was being multiplied by something else. So if this was, say this was x plus 4 up top, I would be able to cancel out the x plus 4 because I turned this into being multiplication and I have x plus 4 on both top and bottom. But since it is not x plus 4, I just have to leave it the way it is. So basically when it says simplify, just look and see if you can get rid of anything and make our expression smaller. So that was the answer that they were looking for. That was A. On B, there's a much more complex one. On B it says, write this down as I say it aloud, 2x squared minus 10x over 4x squared plus 6x. Now we can do the long drawn out way of doing this. Okay, there is a long drawn out way of expanding everything, seeing what they have in common, and then combining them all again. We did that long method. We got to be able to start doing these a little bit faster and trying to separate stuff so that we can write down our values here. So I'm gonna try to reduce this first. I'm gonna try to, or not reduce it. I'm gonna try to simplify it first. What do I see in both the terms on top? I see an x and I see a 2. So if I take a 2 out of this, I'm left with just a 1. If I take an x out of this, I'm left with just 1x. So there it is. If I take a 2 out of the 10, what am I left with? 5. So I'm dividing it, remember that. Okay, so I'm left with 5. If I take an x out of x, I'm just left with, well, 1. But 1 times 5 is just 5, right? So on the bottom, looking at these two terms, I can pull a 2 out, and I can pull a what out? X. So same concept. I pull a 2 out of this, I'm left with a 2. I pull an x out of this, I'm left with an x. Plus, I pull a 2 out of a 6, I'm left with a 3, and I pull x out of it, I'm just left with 1. 1 times 3 is 3. Okay? Now, I'm in my simplified form. This is where it gets a little complicated. There's a multiplication by 0. Anything multiplied by 0 is 0. So, I want to set either of these equal to 0 to identify my excluded value. So I'll take both of the pieces of the product. So I have 2x and I have 2x plus 3. I have to set both of these equal to 0 now. And then I would solve from there. Okay? So I take my two pieces and I would set them both equal to 0 and solve them down from there to see which of which numbers are my excluded values. So here, I divide by 2 on both sides. I'm left with x not equaling 0. So that's one excluded value. My second excluded value will be what I get over here. So I subtract 3 from both sides. That's about 3. I'm left with 2x equaling negative 3. Divide by 2. So x cannot equal negative 3 halves or negative 1.5. However you want to write it is fine by me. They're interchangeable in my mind. So there you are. There are your two excluded values. Next, I want to finish my simplification. So these are my excluded values. It's part 1. Part 2 is I have to finish my simplification. What can I do right here? I have a 2x and I have a 2x. They cancel. And they can only cancel, I repeat, can only cancel because there is multiplication. They are the products. These two multiplied will be a product. These two will be a product. So I'm left with only x minus 5 in the top and only 2x plus 3 in the bottom. And I can't simplify anymore because there is no more multiplication. Any questions there? Okay, going to part C. It has 2x squared minus 14x over 4x minus 28. Okay, I want to try to simplify these by pulling out what I know I can pull out. What do each of these have in common? On the top, sorry. 2 and an x. Okay, so if I pull a 2 and an x out of this one, I'm left with just x. If I pull a 2 out of this one, I'm left with 7. If I pull an x out of it, I'm left with 1. 1 times 7 is still 7. So the top is now reduced to that. What can I pull out of the bottom? I can pull a 4 out. Can I pull an x? No, because there's not an x in the 28, right? So I'm left with, when I pull a 4 out of the 4, I get a 1. 1 times x is just x. Minus, pull a 4 out of the 28, and I get 7. So look, I have an x minus 7 and an x minus 7. They would cancel. So in my total reduced form, I would have 2x over 4. Can I reduce it any more? I could divide each one by 2. So I could reduce this one by 2, I'm left with x. I reduce this one by 2, and I get 2. So x over 2 is my total reduced form. Now, I have to look here, because I broke this down. I have 4, which has no variable in it, so I can't do anything with the 4. And I have an x minus 7. I need to identify excluded values. If you don't have a variable in it, you can't identify excluded value from it, okay? Because 4 cannot be equal to 0. There's no way, no how. So, x minus 7 can be equal to 0. How can it be equal to 0? Well, let's find out. Add 7 to both sides. X then cannot equal 7. That would be my excluded value. So these are the two things that you need. These two things you need. Questions on that part before we move on? Okay. Last example. An example of a moving object. Moving objects will always form a parabolic shape, meaning they will have this form or they will have this form. Okay? So using parabolic ideals, we will do this example. Example 3 says the expression 3.5t plus 0.7t squared, I really wish they'd write this in standard form, represents the distance a moving object travels through time, and they let t be time. The expression 1.4t squared represents the distance the same object moves from rest with twice the acceleration. So it gives you all of this stuff. And then it says, this was your original acceleration right here, 0.7t squared. This is your twice the acceleration, 1.4t squared. Okay? So what they want us to do is to simplify the expression of 3.5 plus 0.7t squared over 1.4t squared. So let's do it. First of all, let's see if we can identify our excluded values. Okay? So I want to take 1.4t squared, 1.4t squared. I want to set it equal to 0. What is it not allowed to be equal to, right? So first, I need to get rid of 1.4, which is multiplication. So I divide by 1.4. 1.4, those go away. I have t squared is equal to 0 divided by 1.4 is 0. Next, how do I get rid of a square root? Does anybody remember? Or sorry, how do I get rid of a square? I gave you the answer. You square root. Indeed, we do. So square and a square root cancel. So t, therefore, cannot equal 0. So there's my excluded value. Now let's go back up and finish solving this problem. Can I pull anything out of these two numbers? 5 and t. Let's make our lives just a little bit easier then, huh? Let's multiply each of these by 10 to make them whole numbers, and then we'll reduce from there. So the reason I say multiply them by 10, because look, we only have tenths place in each of them. So if I multiply everything by 10, like this, 10, I'm really just multiplying it by 1, right? I can multiply things by 1 because 1 times anything is that thing. So 10 over 10 is just 1. So when I multiply this one by 10, I move the decimal place 1 time to the right. And when I multiply this one by 10, I move it 1 decimal place to the right. Remember, I'm just using distribution. So I have 35t plus 7t squared. Now I have to do the 10 on the bottom. So I get 14t squared. Okay, now we have whole numbers. This might make our life just a little bit easier. Or at least seemingly so. What can I pull out of 35 and 7? 7. So if I pull a 7 out of it, I'm left with 5. What else can I pull out of that? I can pull out a t, right? I'm going to need more room. I'm going to jump down here. So I can pull a 7 and a t out of both of those. If I pull a 7 out here, I'm left with 5. Pull a t out of there, I'm just left with 5. Plus, I pull a 7 out of there, I'm left with 1. I pull a t out of there, I'm left with t. Over. I want to be able to factor this and simplify. Okay? So if I'm going to be able to factor this and simplify, I need to start looking at what is multiplied. So I have a 7t here, and I have a 14t squared here. So let's look at it. What can I do with 7 and 14? I can divide 7 out. I can reduce by 7. So if I reduce by 7, I'm left with t, open parenthesis, 5 plus t, close parenthesis, over, since I reduced this one by 7, I'm left with 2t squared. Well, what about those t's right there? Can I do anything with those? Anything at all? If I have a t in common, remember, if I just rewrote this problem and it looked like this, t over 2t squared, what would you do with the t? So what you're saying is you would take the t and you would move it down here because it had an exponent of 1, it becomes minus 1. Because when we divide things like basis, we subtract their exponents, right? So basically what you told me is move the t to the bottom. I agree. Now don't forget that we still have 5 plus t up top. I shouldn't have put a tail on that one. Okay, so just reduce it. I'm left with 5 plus t on top and just 2t on bottom, and that would be our final reduced form. We did that in a lot of steps, but I really could have just done this all in one step right here. I could have reduced by 7 and reduced by t at the same time. Okay, so all I would have had to have done was divided each of these by 7t. And then that would have got me from here down to here. Cool? That's all I need.